iQ-Analyzer-X is featured with a database in the background. So results are stored in a database that is either locally on the machine or on a server that you can connect to. So I open an image file to analyze this. Now the software automatically detects which chart the image shows. I can import this file into the software and have it here on the left in the images section. Now I start a new analysis. So this gives me now my results and all forms of numerical results that I can just see and can go through. If I want to store this for later usage, I say Save New Analysis. And I can store it here. I give it a simple name. So it's demo1234. Demo1234. And can save the analysis. So now if I close it or for later use, I have the software, I start the software again. I can now open an analysis and recall the data from my data set. So here, this is the one that I just took today. I open and I got my results back, which I can now work with as if I would have just analyzed it just before. The iQ-Analyzer-X has a very versatile user interface. So I already added an image file here to my input list and I say Start New Analysis. So you see how fast the software now analyzes the image and presents the data to me. I always have multiple sections in my user interface, which I can also adjust in size and location as I would like to have. So you see, I have the default is that I have my analysis, my file list here, I have my image and I have my results. But if I like to, I can also undock this part here and just move it to another location where I would like to have. So this way I have a flexible interface which I can use however I would like to have it. So now here on my results, I can click through the different representations. So here I got on the resolution part, I got like all SFRs in an overview. And the nice thing is whenever I hover over a certain line, it's highlighted here in the image. So I always know where I am or what data I'm actually looking at. I can also have here for the Siemens star, the nice feature to have the MTF 10, 25, 50 represented in this polar plot. This is a very quick assessment of the results that I would like to see. As the outer ring is the Nyquist frequency and the inner part, that is the measured frequency for MTF 10, MTF 25 and MTF 50. So this way I got a quick overview. I see that here, like the lower left corner is weaker than the upper right. And I see the representation in the image center. If I would like to have the SFR plot, that is also no problem. So here I see I have the results from the image center, and here I got the results from the corner. I see as well that I got this tooltip information, so where I can read the detailed results or detailed see what where this data comes from. It's the same for the dead leaves and for the slanted edges. I can always adjust the plot as how I like it. So you see now with the mouse, I just zoom in so I can have a look at details. So if I just want to know here, I zoom in and zoom out using the scroll wheel of my mouse. I can of course also here click on the zoom buttons up here. If I just would like to have less data in my plot, I can just click here on the legend to add or remove data points from my list. With this little lock, I can also adjust even further. So I could even say I would like to have the legend on a different position. Like move it back to the top. Or I can say I would like to see the results from all stars. But here, or just for the group. I can as well use different scaling for my axis. So typically, or the default is that it's on automatic mode. For some users, it might be useful to have it on a manual scale so that I can compare many cameras with a significant difference in their pixel count. Always have a look here at the different drop-down menus. There you can also select individual data points which you might want to have. For the OECF, I can also let's go have a look there. So I can have the log luminance plot, which is a very typical plot to see. And I can also have my visual noise, and here in a nice polar plot. Also that is quite useful, as I can easily understand the distribution over the patches and have a lot of information in one plot. For color, I see here my delta LCH. So this is related to the color patches, and where I see the difference between the reference data and the image data. While I see here the direct visual comparison, or I can see the numerical results, I can here see the visual comparison, so that I can directly say, okay, here in A1, I got a significant difference in color. And I see in the border that it's also marked red. So that means that I measure a high delta E in this part. If I want to investigate even further, we have a 3D representation. So there I can directly see, okay, the biggest delta E we can find here is in the yellowish colors. So this is a quite nice feature, so that I can quickly understand where are the actual issues. Like here, yellowish colors seem to have a high color error. Or here in a three-dimensional plot, where I can now go in and see details of my reference to the data. Okay. So you see, we have a very versatile user interface where you can always activate, deactivate plots and work with, and always adjust it to your need. How to handle multiple files in the iQ-Analyzer-X. So we go onto a new analysis, and now we open an image folder. Okay, so all images in the folder are now shown here. As I know, they are all from the same chart. I do an automatic detection globally, so that, with the assumption that all images are the same. So now here on the right, I can use different templates. So if you have a test protocol where you need multiple images, you can create a test protocol as a template. So here, my simple example, I need for my test protocol an ISO 100, ISO 400, and ISO 1600 image. So now I drag these images in their certain slot, and only if all slots are filled, I can continue. So this is kind of a reminder, or helps to establish a certain workflow. So now my images are imported, I can start the analysis. Okay, so now I can see my results and can either click here in the analysis overview to get the individual results for my multiple images. But maybe I just want to compare the all results from these images. So what I do here, I mark with control click all 3 images. So now they are added into my plot here and also added to my results list. If I think that this is a little bit too much to have an overview, I reduce that to the image. So now I have the dead leaves results of 3 images in one plot. So this is a great example how to compare multiple results from multiple images in the user interface of the iQ-Analyzer-X. Let's see how I can analyze a video file. So I say new analysis, and here in my import dialog I have import from video files. So now I can select a video file and have my interface where I can say play. So this way I go to the position in the video file where I would like to go. And here I can now say, okay, take an image. So I can close. In my import dialog now, I have this cropped file from the video. So this is an image file that was extracted from the video file. The software automatically automatically detected that it is a TE230, so color checker SG. So this can now be imported, and yeah, I can now also analyze that. So that's quite easy. Now I got my numerical results for that. So I did this color analysis, and some of you might have noticed that the ROIs on the patches aren't set ideal. So a great chance to show you the manual detection modes. So I close this and I select here for the detection the semi-automatic mode. So now I start a new analysis and I got this window. Here I see all automatically detected region of interest. You see they haven't been set ideally. So now I have here these markers where I can just grab all or can just grab the master ROI and place all ROIs where I would like to have them. Say OK, and the analysis now is performed using the new region of interest. So you see I have a very easy and versatile way to adjust to images that might not have been captured ideal. Here, of course, forced for the demo, but if you have strong distortions or any other issues where the software might not detect perfectly, you always have the manual mode to adjust. So with the database behind the iQ-Analyzer-X, you can recall results whenever you like to. So the database can be your main storage of results. But maybe you would like to have something to share with colleagues or to put into a PowerPoint presentation. So for that, you also can export PDF. Or if you want to do your own analysis and do your own reporting, you can also export an XML file. So the XML contains all information that are shown here in the analysis. If I select PDF, we have multiple options. The main thing is that you can have different templates. So the iQ-Analyzer-X comes with a default template. If you would like to have your own template, your own reporting, get in touch with us. So here I have resolution, always say, okay, I don't want to have the shading report, I don't want to have the distortion report, and I'm fine with these three. So now I can export that and say, okay, I just want to have that as report. Yes, I would just like to replace that. So now the software generates in the background the PDF report. If I now open it, I see I have my report with a default, in a default template. So I have my region of interest stored, but also all the plots that are in the user interface, so that I have it stored and can use for my own reporting. Of course, this can also be done with recall data. So the nice thing is, as you have your database, you can also, in half a year later, you can just recreate your report. Also, if you, for example, have a new template, these reports are generated based on the database. So that's a quite nice feature of the iQ-Analyzer-X. How does the iQ-Analyzer-X handle reference data? So if I import an image here into the software for further analysis, the software automatically detects that this is a TE42 version 2 in a 4:3 aspect ratio. What it does not have is the reference data, so the specific measurement results of this chart. So for example, the color data and the density. Per default, it uses the example from the chart file. So that is the batch measured data. So that is already a good data, but for be really precise, you should use the data that really comes with the chart. So how can I do that? So let's cancel here and I go into the configure dialog. There I find reference data. Now I can select the file that where I would just like to store reference data for. So here's the TE42 version 2 4:3 aspect ratio. And now I can import an image file that I have, or a reference file that matches this file. Okay, so this is now imported into the database and it can now be used. So this file can be obtained from image engineering for the TE42. So you can just download that from our website. You get information when you receive your target. If you want to do that for other targets like an OECF target or have your own color checker, you can also edit these files. So other than in the iQ-Analyzer version 6, these are now reference file are text-based. So you can use a text editor to adjust the files and import that. So now as I have added a new reference file, let's see how that looks like. So I open an image file, which is now also identified as a TE42 version 2 4:3. And now I can still select the example from the chart file, but I can also select the just imported file with the serial number of my specific chart, which makes it a much more precise measurement as any chart-to-chart variation that is low for image engineering products, but is still existing. So I can work with the exact data, which is the best possible way to do. Okay, let's have a look at some of the details in the configure menu. So if I go to configure, I can make a lot of settings in the background. For details, have a look at the manual, but here I give you just a quick run through. So under general, we have the details to the database. So so you can have a local database that just runs on your machine, or you can have a shared database. So that would just need to be a database that can follow the ODBC protocol, and that can be on the server. The nice thing is multiple people can work on the same database. So if you have a team of, let's say, 5 people, all would connect to the same database. So all can also restore, get the results from the other colleagues and work with that. So that's extremely useful. Here you connect the database and can check the connection. We also feature multi-language support. So we have English as a default, but then we also have German, Japanese, and Chinese. So if you would like to use the user interface in your own language, that's where you can configure it. The dongle is also configured here. So the license of the iQ-Analyzer is managed using a USB dongle. We've decided this way because this is an extreme secure way. We don't need any internet connection to work properly. And so for now, that is the way how to manage the license. For that, we feature a local workflow where you have the USB dongle is connected to the machine, to the PC that you are currently working with. But we also have a network functionality. So you can have the dongle connected in a network share. See the manual for more details, but then you can also use that dongle via the network. Also here the use case might be you have multiple people working, so you can have a dongle with like 5 licenses on that, and then but people can have on 10 different machines have the software installed and just use it very flexible on the machine they would like to have. Then we have settings here for the analysis setting. So you can define a lot of different details of the analysis, like setting how exactly the linearization is done, how some sourcing is done, how fittings are done. So really detailed analysis of or detailed settings of the analysis. And you can then also store multiple different settings. So I can make some changes here and then save this setting with a new name. So this is now my setting, and I say the setting as shown in demo. So with the description, I can remember later on what I've done. So we want to avoid that you have now setting 1, 2, 3 and you don't know exactly what it is. So now you have stored it under with the name that you would like to have. So the visualization can also be customized. So some limits. So for example, in color, a certain error gets turned red, others are yellowish. So this is what can be defined under visualization. We have the reference file import. That's what we already talked about in the reference file. So with the target, if you have detailed data of your target, so color data, densities, and so on, you can import that here. So then it's stored in the database. Also, that means that if you have a shared database, all colleagues can participate in this data and can make use of this data. Specifications for the UTT, or a special target where you have specifications and you can get information if you passed or failed the specification, can be imported here. And a very nice feature is the automation, where you have a command line and a hot folder functionality. But that's, I'm going to go into detail with that in another video. So let's have a look at the automation features. So we have 2 main input ways or interfaces into the automation. So one is the hot folder. So I can add a folder here. And I say, okay, I have this hot T42 version 2 folder. I select that. And I can now make different settings to this folder. So for example, I say, I want to have my settings for this, and I want to automatically save it to the database after the analysis. And I would like to have, I say this is a T42 version 2. And I select this is my reference data. So now this way I created a specific hot folder for my that I can use. So now I can have here now this hot folder, and I have an example image. So I just copy it into the hot folder. So now going back here, I see here my jobs. I can now activate the hot folder, and I see that this will now automatically analyze the image. If I copy a new one, it will also analyze these images. So I can say automatically start hot folder watching at application start. So I could have a server where the software is running and just continuously watch it, has a look on the hot folders. So that is of course a very powerful tool, especially if you have always the same task of analyzing very similar images. You can have just the folder and throw the images into this folder and let the software do the job. So now have a look at another way for automation. Besides the hot folder, we also have the command line interface. You have different possibilities to control in the command line, and to make it most easy for the user, we made a workflow where you can can create a sample file. So in this example here, I just select the file that I would like to analyze. I also say, okay, my different settings. So I would like to save the analysis to the database. I use my settings, and I use the local database. The chart detection, in this case, I would like to do it manually with my reference data that I already used. So now I can create a batch file. So this batch file, I just save it to the desktop. I say sample batch demo 1. Okay, this has been successfully been created. So now I can, what happened in the background, this batch file has been created, and I can just double click on it so that I can also start the execution. Of course, I can then also open the batch file for my editing. So see now, as the software was open, the analysis has been performed and already been stored. But now if I also see, so this is the batch file as I created it. So you can of course then use this as a starting point to create your own files and to make your own tools that interfere or have an interface into the iQ-Analyzer-X.